Good day everyone, I'm Kerby and Pascual from BSRK2B, together with my groupmates Christine Paraso and Jasper Peralta. And we are here to discuss our report regarding what is nanotechnology, who coined the term nanotechnology, where and when it first started, and what are the applications of nanotechnology. What is nanotechnology? Nanotechnology is a field of research and innovation concerned with building things, generally materials and devices. On the scale of atoms and molecules, a nanometer is 1 billionth of a meter, 10 times the diameter of a hydrogen atom. Nanotechnology is hailed as having the potential to increase the efficiency of energy and consumption, help the environment, and solve major health problems. It is said to be able to massively increase manufacturing production and significantly reduce costs. Products of nanotechnology will be smaller, cheaper, lighter, yet more functional and require less energy and fewer raw materials to manufacture, claim nanotech advocates. Who coined the term nanotechnology? The ideas and concepts behind nanotechnology and nanoscience started with a plenty of talk entitled There's Plenty of Room at the Bottom by PCC's Richard Feynman at an American Physical Society meeting at the California Institute of Technology on December 29, 1959, long before the term nanotechnology was used. In his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. Over a decade later, in his explorations of ultra-precision machining, Professor Norio Taniguchi coined the term nanotechnology. It wasn't until 1981, with the development of the scanning tunneling microscope that could see individual atoms, that modern nanotechnology began.
Okay. So, the history of nanotech. American physicist Richard Feynman is considered the father of nanotechnology. He introduced the ideas and concept behind nanotech in a 1959 talk titled There is a Plenty of Room at the Bottom. Feynman did not use the term nanotechnology, but instead he described the process in which scientists would be able to manipulate and control individual atoms and molecules. Modern nanotechnology truly began in 1981 when scanning tunneling microscope allowed the scientists and engineers to see and manipulate individual atoms. Scientists Gerd Binning and Heinrich Rohrer won the 1986 Nobel Prize in Physics for inventing the scanning tunneling microscope. The Binning and Rohrer Nanotechnology Center in Zurich, Switzerland, continues to build on the work of these pioneering scientists by conducting research and develop new applications for nanotechnology.
So, a pleasant day to everyone. I am Christine Paraso of RK2B, and in this video, we will talk about the benefits and application of nanotechnology in our current modern world. So without further ado, let's start with the discussion. I hope that we all can learn something from our video. Though nanotechnology might appear to be a bizarre or like a far from future idea, it long had been exist and help our society. Some useful application can be seen in the fields of medicine, electronics, food, fuel cells, applied to get better air and water quality, chemical sensors, sporting goods, and fabrics. So now let's officially start with what are the applications of nanotechnology. So in everyday materials, and processes. Um, Nanotechnology can be used or applied to get clear nanoscale films on eyeglasses, computer and camera displays, windows, and other surface that can make them water and residue repellent, anti-reflective, self-cleaning, resistant to ultraviolet and infrared light, anti-fog, antimicrobial, scratch resistance, and electrically conductive. In this slide, we can see that nanotechnology also can be applied in transportation, such as where cars, trucks, airplanes, and others are part of. Also in sporting goods, like the baseball bats, tennis rackets, bicycle, motorcycle, helmets, and others. Electronics and its application. Nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster and smaller, more portable systems that can manage and store larger and larger amount of information. Transistors and basic switches that enable modern computing have gotten smaller and smaller through nanotechnology. Smaller, faster, and better transistors may mean that soon your computer's entire memory can be stored in a single tiny chip. Medical and healthcare application. So the example of these were the commercial application have adopted gold nanoparticles as probes for detection of targeted sequences of nucleic acid, and gold nanoparticles are also being clinically investigated as potential treatments for cancer and other diseases. Energy application. Nanotechnology is finding application in traditional energy sources and is greatly enhancing alternative energy approaches to help meet the world's increasing energy demands. Many scientists are looking into ways to develop clean, affordable, and renewable energy resources, along with means to reduce energy consumption and lessen the toxicity burdens of the environment. Environmental remediation. In addition to the ways that nanotechnology can help improve energy efficiency, there are also many ways that it can help detect and clean up environmental contaminants. Nanotechnology can help meet the needs of affordable, clean drinking water through rapid, low-cost detection and treatment to impurities of water. And nanotechnology enabled sensors and solutions that are now able to detect and identify chemical or biological agents in the air and soil with much higher sensitivity than ever before.